Hi there. Now we're going to get into the different mechanisms that we use to protect our body. So there are innate or built-in protective mechanisms that we were born with. Things like our skin, our mucous membranes, our acidic environment of our stomach, the acid mantle of our skin. These all help to protect us from potential pathogens. We also have an adaptive immunity. Adaptive immunity is something that we build up. So we're not born with it, but we have the cells that will eventually recognize a pathogen and they will attack that pathogen. And when they attack that pathogen, they do it really well. The major difference between the innate defenses and our adaptive defense mechanisms is innate is going to respond immediately to the breach in our barriers. Adaptive have to build up an army before they can actually attack. But once they attack, they wipe out the pathogen, and then they remember that same pathogen. So we can look over here at our innate defense mechanisms. Your text calls it innate immunity. I don't really like that word for our innate defenses because we don't provide actual immunity to the different pathogens. Oh, sorry. There we go. So things that belong to our innate defense mechanisms are skin, our mucous membranes, our gastric juice in our stomach. And then we have the non-specific defense mechanisms that are internal. So once the first line of defense is breached, then the second line of defense is going to come into play. And so these are the different white blood cells like your neutrophils, eosinophils, basophils, your macrophages, your natural killer cells are all going to be part of this defense. Different chemicals, different cytokines that your cells give off that activate other activities like inflammatory responses or fever, things like that. And then your third line of defense is your adaptive immunity. So this is going to take a little bit of time to respond to the pathogen, but once it does, it's going to produce an army of either T lymphocytes or B lymphocytes that will attack the pathogen and remember the pathogen. So we've talked about some of the innate defenses already, but I'll quickly go over them again. The very first line of our innate defenses is our skin and our mucous membranes. So that's going to protect us from anything that tries to get into our body. Our skin is a very important barrier to the internal environment. If our skin is gone, then we don't have that protection anymore, and we're way more prone to infections. Mucous membranes line every area of our body that is open to the inside and will trap pathogens in the mucus. And then we have ciliated cells that will push that mucus towards the throat or towards the external environment. Our second line of defenses are the chemicals that our cells make, chemicals that are given off by the pathogens, responses to the chemicals, and the different white blood cells that attack those pathogens. So how does our skin provide protection? Well, I told you that it's a barrier. It is a barrier. It contains its own microorganism flora. So we have living cells all over us that protect us from pathogenic cells. They live with us and they provide us with protection because they're going to outcompete for any type of they will outcompete any type of pathogen that tries to get onto our skin and get a hold on our body. We also have in our sweat, we have antibodies, and we have enzymes that will decrease the ability of bacteria to grow, to replicate. And sweat is slightly acidic, and that gives us an acid mantle. The mucous membranes line our body, which I already mentioned. They provide mucus, which is mucin that interacts with water, produces that mucus. And then within the mucous membrane, we have the cilia cells that push the bacteria towards the entrance so that the bacteria don't get into our system, or the pathogen doesn't get into our system. These are very important mechanisms to protect us. I didn't talk about gastric juice, but I've mentioned it already like 2 times. So our stomach has gastric juice in it, and gastric juice is very acidic, so most bacteria will die in the gastric juice, and so they won't get into the small intestines. But and so these barriers are very beneficial. And if microbes get through the first line of defense, then they're going to come up with the second line of defense, our innate cells and physiological processes, internal, as well as our active immunity, adaptive immunity is going to be activated. So innate defense mechanisms, we have neutrophils and macrophages. I'm going to show you how neutrophils work. These are your first responders, and they arrive to the site typically very rapidly. Sorry. And they are phagocytic cells, so they're going to go along and they're going to attack the pathogen. And I actually have a video of this if it'll work. Here we go. That's a white blood cell that you're seeing there. Chasing after some type of bacterial cell. And there he got him. Okay. So I hope you enjoyed that. And we also have macrophages. Macrophages are also phagocytic white blood cells, but these are white blood cells that clean up. They're considered clean up cells. Hold on one second. All right, I'm back. Wow, I went through all of these already, sorry. I was talking about macrophages. Macrophages are also phagocytic white blood cells. And the difference between a macrophage and a neutrophil is when a neutrophil attacks a pathogen, it really just kills off one pathogen, and then it itself will also die. It's the most common white blood cell, and it's the first responder, but it doesn't do a huge amount of work because it can't. Macrophages, on the other side, are going to stay in your system. They're going to attack the pathogens. They're going to clean up all the mess. So they are basically the major resident cleaners. And I have a video on macrophages as well, because macrophages rock. So let's watch this. So this is a very interesting video. I'm not gonna watch the whole thing with you. So right here, okay. Are you okay? Okay, so just so you know, before anything. Harold has a paper cut. And so we're going to see the response to this paper cut inside of Harold. It's called the angry macrophages.
United cells of Harold.
I'll have the team meet you at the site. Godspeed, Harry.
So it's going to move to the site, and then it's going to squeeze through via diapedesis. So what we're going to see right here, it moves through the blood vessels. Probably not the way, in fact, I'm positive this is not the way white blood cells actually work, because they don't have, well, they don't have these type of tools, so. But it's still interesting, and they do clean up the environment. No, I took vitamins. All right, so I'm going to stop this. It's kind of a funny video, but you can totally watch it on your own. It's a long video. I just like the angry macrophage part because that's what, well, that's what I'm looking for. So, and let's go back to our lecture. Paul Chang. Okay. So you've seen how neutrophils and macrophages work. Neutrophils get to the pathogen. They're the first responders. They're going to kill off pathogens, but they don't do a lot of work because they can't. Macrophages will stay there and they will clean up all the messes. And so what are they actually doing when, so as I told you, macrophages don't have bats, they don't have lightsabers and stuff like that, obviously. What they do, both of them engulf the pathogen via phagocytosis. They produce a vesicle. That vesicle then will bind to either a lysosome or a peroxisome. And the enzymes in the lysosome or peroxisome are going to degrade the pathogen. And then the waste product can be released via exocytosis. And so here's another picture showing that same process, just a larger picture. Basophils and mast cells have similar processes as well. They both release chemicals. They release heparin. Heparin is going to increase the fluidity of blood. So blood cells can move faster. And then histamine makes your blood vessels more leaky. so that you can get the blood cells to the site of the